Okay, let's talk about interface flow terms: upstream, downstream, unidirectional, bidirectional interfaces. Which way does the current flow? The interface river starts at patient admission, registration. That is the first step in the patient workflow. Consequently, all other systems are considered to be downstream from that point. The farther away a system is in the patient workflow, the farther downstream the system is. The patients starts at admitting registration, then they go to the hospital information system, or HIS, and then they go to other systems like RIS, CIS, LIS, radiology, cardiology, lab. So an order message traveling from the hospital information system to the RIS would be described as flowing downstream. However, a result message traveling from the RIS to the HIS would be described as flowing upstream. You have to have a good understanding of the patient and corresponding data flow to be able to know what is downstream and what is upstream. So this is Lake Itasca in Minnesota, and it's where the Mississippi begins to flow. This is the headwaters of the Mississippi River, and you can see these people here are easily walking across the Mississippi River. Now, halfway down the Mississippi River is the town of St. Louis, Missouri, and that's about where our RIS system lives. Radiology and PACS are somewhere around St. Louis if the interface was the Mississippi River. Now here you have the same interface flow, or the same river. It's the mighty Mississippi River. It's getting close to New Orleans at this point, and so it's downstream of St. Louis. And you might want to think of each of these little barges as messages traveling down the interface river. So you have to know where you are on the river to know what is upstream and what is downstream from you. Now, which direction does that interface go? An interface can be unidirectional or bidirectional. A unidirectional interface is like a one-way street. Information only flows in one direction. A bidirectional interface will allow data to flow in either direction, but not at the same time. A bidirectional interface is like a flag crew when one part of the street is closed. They hold traffic on one side while the traffic flows on the other side. Then they reverse the process, stopping the traffic and letting the held-up cars go, right? So if you're coming this way on the street, you have to stop. You can't go anywhere, right? These people, they can go slowly through here. So this interface is flowing in this direction right now. When they flip these signs, those cars will stop, and then these messages, if the cars were messages, can go. So they can go in either direction, just not at the same time. That'll be important later on. Which works best? The network engineer will decide which type of interface will be used to connect your systems. He or she will look at the anticipated workflow, the patient volume, the amount of data being moved at the busiest time, and hopefully he or she will consider how that affects patient care. Let's say the network engineer is connecting the HIS and the LIS. Note, this is for instructional purposes only and does not represent the real way a HIS and a LIS would be connected. They could be connected in one of three possible ways. You could have a unidirectional interface, right? All the data flowing from the HIS to the LIS. That may or may not work in the real world. You can have a bidirectional interface where data flows from the HIS to the LIS, and then from the LIS to the HIS, and then back and forth. Again, remember, it can only go in one direction at one time. It can't go in both directions at the same time. Or you might use two unidirectional interfaces, with one going this way and one going that way. And then you can get that circular flow where things can be flowing on this unidirectional interface and things can be flowing on that unidirectional interface, and they can flow both directions at the same time. You just got to have two unidirectional interfaces. So again, they could be connected by a unidirectional interface if data needed to flow only in one direction. Now remember, it can only go in that direction. So to go back to this diagram, if the HIS only sent information to the lab information system and didn't need results back, this would work. That's probably not going to work in a real-world scenario because you want the lab results back. They could be connected by a bidirectional interface. This works well for two systems that need to exchange data with each other at different points in the patient workflow, such as orders going to the LIS and then results coming back to the HIS after the tests are done. So again, let's go back to the diagram, right? So the patient gets sent and the order gets sent here, then there's a time delay while the patient gets their blood drawn and tests are run, and then the report comes back. So that might work well because they don't need to send information simultaneously. There's some information coming this way and there's some information coming that way, and it's usually moving at 2 different times. Or they could be connected by 2 unidirectional interfaces. This works best for systems that need to exchange lots of data at the same time. But remember, cost is also a factor. Each interface costs about $15,000, so building 2 is an expensive solution. So here you have both systems connected by 2 unidirectional interfaces. So, right, this sort of is a one patient at a time model. The patient comes over, get their test, information comes back. If you've got 20 people all going to the lab and 20 results all trying to come back, and you want that all to happen, you know, on a busy morning in a hospital, you might want to have 2 unidirectional interfaces so orders can be traveling this way whenever they need to be sent, and results can come back as quickly as possible that way. So that is all about interfaces and flow and what directions they go in. Thank you for watching.